आप लोगों ने कभी रीड आउट किया होगा नॉर्मल डिस्ट्रीब्यूशंस, बाइनोमियल डिस्ट्रीब्यूशन, पॉइसन डिस्ट्रीब्यूशन, या आपको आगे you'll learn about them. So इन सारी डिस्ट्रीब्यूशंस के लिए हमारे पास जो सबसे इम्पोर्टेंट चीज़ होती है दैट इज़ कॉल्ड रैंडम वेरिएबल. सो आज हम रैंडम वेरिएबल पढ़ेंगे कि सो लेट्स स्टार्ट विद रैंडम वेरिएबल. सबसे पहले इसकी डेफिनेशन कि हमारे पास रैंडम वेरिएबल होते क्या हैं. अगर इसकी हम डेफिनेशन देखें सो लेट मी स्टार्ट विद सो सबसे पहले हम रैंडम वेरिएबल देखेंगे, उसकी डेफिनेशन देखते हैं. अ रैंडम वेरिएबल a random variable is a function from sample space to real number. So it is the definition के random variable हमारे पास एक function है from sample space to a real number. So let's do the same example, rolling two dice. So let's roll two dice. अगेन हम हमारे पास एक रेड डाई होगा एंड द अदर वन इज green die. Okay, if we write its sample space, so the sample space will look like something. So our sample space is basically a set where each outcome is a pair ij such that I is less than or equal to 6, and similarly j is less than or equal to 6. So it's between 1 and 6, and it's something that we have discussed again and again. So let's define a random variable x, or let's define x or denote x, the sum of two dice. So now we defined x as the sum of two dice. So for example, if we have an outcome, maybe for example an outcome is 3, 5. So now if we define x on it, so x will give us the value 3 plus 5 as 8. And how about if we have, maybe we have an outcome, so it will be 8. So in general, for any ij, it will be I plus j. So you see, it is a function from the sample space to a real number. So all the time a random variable is going to give you a real value. So right now I'm not talking about the probability of the random variable. Right now I'm just talking about the random variable. So random variable could be anything. For example, we can define y as the max of two die values. So for example, अब हम if we have 3 5, so what does y will give us? In fact, whatever is maximum here, that will be the output here. So the max of 3 5, I mean, you can just, if you want to put it in another way, then that is 3 5. So obviously it will give you the 5. Generally, for any pair ij, it will give us the max of I and j, whatever the max is here. So for example, yf 3 6, it is going to give us the 6. So now you see, everything that is an output depends on the function which we have defined. So here, for example, we defined as y as the max of the two die. Here our x was the sum of the two die. We could have also defined maybe an average. Maybe z is the average of two die values. So for example, z of ij, mean any pair ij, how it would look like? I plus j divided by 2. So for example, z of 4 6, that would be 4 plus 6 divided by 2, so it is 5. So you see, it can be defined depending on the situations, or depending on your objective. So again, here a random variable is a function from the sample space to a real number. So all the time we are getting real numbers. We can define other such functions as well. So here we used x, which was the sum of the two die. So x of 3 5 was basically, it gave you an 8 because x is the sum of the two die. Y was the max of the two die values. So for example, it is 3 5. So whatever is maximum on the values of both die, you will get that one. So here it is 5. Again, we defined another random variable that was sort of the average of two die values. So here z of I of j will give us the average of the two die values. So it's really important to understand a random variable, because it's the one of the building blocks of doing any kind of distributions. So let's do another example again. So here we have now 5 dice in a hat. Okay, so one die is 4-sided, the other side die has 6 sides, the other die has 8 sides, the other die has 12 sides, and the other die has 20 sides. So we have 5 dice in a hat. So we are going to choose a die randomly, and then we are going to roll it. So first of all, what will be our sample space? So since we have 5 different dice, so I'm going to describe my sample space in a way where the first element in a tuple will tell me the die, and the second tuple will give me the value once it is rolled. So in our sample space, we write it as 1 1 1 2 1 3 1 4. So these are all outcomes when a die has 4 sides. These are all outcomes when a die has 4 sides. And similarly die 2 with 6 sides, when you get a value 1 after rolling, you get a value 2 after rolling, you get a value 3 after rolling, you get a value 4 and maybe 4, 5 and maybe 6. So these all are outcome corresponding to 6 sided die. Similarly, 8 sided die, you may have 1 once it is rolled, and then you'll have at the other end you'll have 8 when it is rolled. So 8 such outcomes, 8 sided. So now 12 sided, when you get 1 after rolling, on 8 sided die, 2 after rolling, and 12 after rolling. So 12 such outcomes. And now the 20 sided die, you get 1 after rolling, 2 and 20 such outcomes. So 20 sided die. So if you count it in our sample space, the number of outcomes 4 plus 6 plus 8 plus 12 plus 20, that give us the number of outcomes here are 50 outcomes are here. One thing to check out is that all these 50 outcomes are not equally likely. Not equally likely. You can just check it from yesterday's lecture, that all of the outcomes are not equally likely. So let's define a random variable x on outcome w, which will give us the value that is appearing on the die. So if you look at it, any such outcome in our sample space was actually represented in this way, where I was the die and the j was the value appearing on the die. So if x is defined, which will give us the value on the die, that will give us j, because value on the die is represented by the second component. If we are interested, we can define another random variable which can tell us about which die we are talking about. So y could be defined in a way which will tell us about the particular die. So in that case, what we get is I, which in fact tells us which die we are talking about. So for example, here it was one in which we were talking about the die with 4 sides, 2 die with 6 sides, and 3 with 8 sides, 4 with 12 sides, 5 with 20 sides. So for example, if I get a value 2, 1 with random variable x, since a random variable will give us the value appearing, so our value here will be 1, and Similarly, with same input we'll get 2, which tells us that we are talking specifically about the second die. So random variables, this is another example of the random variable. Okay, one common notation which is being used a lot. So if we know that, if it is understood that I j is our input, such that I tells us about the die and j tells us about the value appearing on the die. So in that case, sometimes we use just a shortcut that x is equal to j, uh, which is the same as the this one. So this is a shortcut notation. Okay, now we are going to talk about the probabilities of the random variable. In fact, we just saw some random variables such as x, y, and z. Uh, we cannot, in fact, calculate the probability of the random variable. It doesn't make any sense. So it's wrong to calculate the probability of the random variable. Why? Because probability are calculated for events. In fact, we have done several example calculating the probability of different events. So but when we say x is equal to 5, for example, again if we take an example of the rolling 2 die, five, 6, 1, 2, 3, 4, 5, 6. So again, if we define x in a way that gives us the sum on the 2 dice, so x of I j basically gives us the sum of the 2 dice I and j. So when we say probability of x is equal to 5, what does it mean? It means all such outcomes so if we look here, 1 4 will give us sum as 5, 2 3 will give the sum as 5, 2 3 gives us sum as 5, and 1 4 give sum as 5. So 1 4 2 3 3 2 and 4 1. So in fact, when we say the probability x is equal to 5, it means now we are talking about an event where each outcome, if you sum the value of the 2 die, that will give us the value equal to 5. I mean, if you take any outcome here and if you apply 3 2, that will give us the sum as 5. So in this event we have all such outcomes which will give us the value as 5. So when we say probability x is equal to 5, we actually mean that what is the probability of an event where each outcome will give us, if you sum it, will give us the value 5. So in fact, how many outcomes are in total? Total there are 36 outcome. Okay, total are there are 36 outcome. And how many outcomes are in this event? 4. So it gives us the value 1 over 9. So it gives us the probability as 1 over 9. So it's very important that we understand these notations. So I will repeat it, that uh, finding the probability of random variable is wrong. You cannot calculate the probability of the random variable. In fact, what we do is we define an event where which contains all outcome. For example, in this case, we were interested in the probability of x is equal to 5, where x is defined that it is the sum of the two die. So here I am saying what is the probability x is equal to 5 means what what is the probability of an event where each outcome will give us the value 5. So here are 4 such outcomes, and if you divide by the total number of outcomes, that will give us the probability. We can we can, how about probability x is equal to 6? It means now an event where each outcome will give us the value 6. So if you look here, 5 plus 1 gives us the value 6, 4 plus 2 6, 3 plus 3 6, 4 plus 2 6, and 5 plus 1 6. So the number if I enumerate all the outcomes, it would be 1 5, 2 4, 3 3, 4 1, 4 2, and 5 1. So how many outcomes are in this event? It's basically 5. 1 2 3 4 5. So we have 5 such outcomes. 5 over 36. So how about probability x is equal to 7? I think this is this diagonal. So it gives us 7, this, and this. So there are 6 such outcomes in the event. If we write it, it's 1 6, 2 5, 3 4, 4 3, 5 2, and 6 1. So the probability of this event, is 6 over 36. So 1 over 6. So and this outcome has the highest probability, and you can just see x can't If x is defined to be the sum of the two die, so the values that x can take on will be 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So these are the values that x can take on. So because x basically gives us the sum of the two die values. Let's do one more example. So let me change the color of the. So flip a coin until head appears, and now let's define x. Let x be the number of flips. So let's make a sample space. So and remember, it has including head. So in the sample space we'll have head, tail head, tail head, and if we I mean at jth, if we flip the coin jth times and the head appears only at jth position, then it can be written as something j minus 1 such, and the head and up to infinite. So what is the probability that x is going to take a value 1? So in fact, what does it mean? It means, what is the probability that we'll have only one flip? Only one flip, because x is defined as the number of flips. So an event in this case will have only single outcome. So it is an event which contains only one outcome, that is only head. So probability of the head is 1 over 2. Probability x is equal to 2 means we need two number of flips. So the event here contains again a single outcome, tail, head, and the probability is 1 over 4, and the probability x is equal to j similarly correspond to this event, and the probability is 1 over 2 j. Sometimes we write inequalities as well. For example, how about if we say probability that x is less than or equal to 3? It means the probability that x is equal to 1 plus the probability that x is equal to 2 plus the probability that x is equal to 3. So you can check out that all these events are disjoint. So that's why we can sum its probabilities. So the probability will be 1 over 2 plus 1 over 4 plus 1 over 8. So whatever that gives you a value, maybe 7 over 8. How about if we say we are interested in calculating the probability that x is uh, greater than 3? So an easiest way would be, if you see, we can solve it in this way. The probability that x greater than 3 plus the probability that x is less than or equal to 3 gives us the value. If you sum the probabilities, it will give you the value 1, because it contains all the outcomes in the sample space. So from here we can calculate the probability of x greater than 3 as 1 minus probability of x less than or equal to 3. So we can use different inequalities in different ways to calculate the probabilities. So